right. Basically, the counting principle is used to find out how many combination or choices of items that you can have, okay? For example, a real easy one is this. If I have a combination lock, okay, I have a combination lock like on your locker, okay? It has three numbers in the combo. Okay, now, your particular one goes to 49, right? Okay, so if it was 0 to 49 is the possible numbers, okay, 0 to 49 is the possible numbers. So, how many options, how many numbers is that for the first digit of or the first number of your combination? How many total numbers are there then from 0 to 49? 49. No. 50. Yeah. Okay. So for the second number, there's still 50 because you could have a combination that was 42, 42, 42. Okay. Some of you do still forget that, even though it's 42, 42, 42. So the third number, there's still 50 possible numbers. Okay? So what I want to know is this. I want to know what is the probability that my combination is 9, 19, 40. Okay, we want to know the probability of a combo that is 9, 19, and 40. Okay, is there any other way to get that combination? No, because it has to be in that order. Okay, so there's 50 choices each time I turn the knob. Okay, so to find out what our probability is, we have to have, for probability, we have to have favorable outcomes over total outcomes. Well, to find out how many total outcomes there are, I simply, total outcomes is equal to 50 times 50 times 50. Okay, well, we know 50 times 50 is 2,500. So that would be 2,500 times 50. So that would be 0, 0, 0, 5, carry my 2. So 125,000 possible combinations. And there's only one that we want. So the probability that you're going to have your combination, you guess 9, 19, 40, would be 1 in 125,000. Yeah, it'd be 50 to the third power, but you still got to come up with 125,000. So that would be your probability that you guessed the combo. If you didn't know your friend's combo, that would be the probability that you guess your friend's combo right the first time. Okay? Now, if you were smart enough to figure it out, you could obviously do it 125,000 times and eventually get there. But you can imagine if you just sat there and went 0, 0, 0, not it. 0, 1, 0, not it. 0, 2, 0, not it. That's how you'd have to do it. Okay, that's how you get 125,000 possible combinations. Okay? So, obviously, not real good probability. Okay? It's sort of high up there. All right? But that's the counting principle. Another way to do it is this way. Let's say we're at Subway. Okay, we're at Subway. We're going to order a sandwich. How many types of bread? Anybody know how many types of bread they have? Is there 6? Okay. So there's 6 types of bread. We'll say that there's 5 meats. They have 4 cheeses. And they have probably 6 veggies. And they have, let's say, 4 dressings. Okay? So, we want to know how many possible combinations there are. Now, this only works if I'm choosing one from each group. Okay? Obviously, most of us put, more than just one veggie on there, or usually don't put more than one dressing, but, but we're just saying if I ordered one from each category, okay, how many different combinations there would be. So, you would say 6 times 5, times 4, times 6, times 4. And that would be 120, 780, 0, 2, carry my 3, 780 would be 4, 2, carry my 3, which would be 3,120. 3,120 possible combinations of sandwiches. So that's quite a bit. Quite a few. Okay? So that's another way that you have the counting principle. Okay? Now, one of the major things that I always like to talk about here is the lottery. Now, I don't personally play the lottery. I've played it like one time in my whole entire life. So, whether you do or don't, I'm not covering that subject. Okay? What I want you to see is the mathematical part of it. And I don't even know, to be honest with you, I don't even know all the ins and outs of all the new ones they got. Okay? So what we're really talking about is the lottery when it first started here in the state of Texas. It was 50 numbers. Okay? And you had to get 5 of them, 5 of the numbers. Okay? So, if you have number 1, number 2, number 3, number 4, and number 5. Okay? A simplistic way to look at this, and there's a more complicated way that will get you the exact probability, but this will get you an idea of what it's like to win the lottery. Okay? And now it's even, the odds, or the probability now is even greater than what I'm fixing to show you. Because I think now they have up to like 55 or 60 numbers, and they have to, you got the Powerball thing, you got, all that stuff. But when that first little ping pong ball comes out, there's how many numbers in the hopper? 50, right? Okay, so the first one's 50. Okay, now when that one comes out, can that one be used again? No. So it would be 49 for the second number, 48 options for the third number, 47 options for that next number, and then 46 for that number. Okay? Now, if we take and multiply those together, I'm going to do it on a calculator here so I don't have to take the time to. Okay, so the total of 50 times 49 times 48 times 47 times 46 is equal to 254,251,200. And realistically, probably another way that we could do it would be, 50 raised to the 5th power. That would be 1, 2, 3. Yeah. Realistically, it's probably closer to 312,500,000. Okay, so for you to pick the one winning combination of numbers, realistically, it's right around this. 312,500,000. Okay. Now, the reason why people win the lottery is because there's more than that many numbers being guessed. In other words, out of the whole state of Texas, the reason people win the lottery is because if there's, 300 million numbers being guessed, then you've got a good shot that somebody is going to win it. Okay? Because if let's say Nicole went and played, Derek went and played, the odds of you two guessing the same numbers or wanting the same numbers is not real likely. Okay? And so you get enough people that are buying, and if Derek's buying 3 different tickets and Nicole's buying 5 different tickets, and all of her tickets have different combination numbers, and all his combinations have, all his tickets have different combinations, well, there's 8 already just with 2 people. And there's people that go out and pay, when it's large, there's people who go out and buy 100 of them. Okay? So eventually, yes, you're going to have somebody win it, because eventually what this tells us is there's only 312 million different combination of numbers. Okay? Now, there obviously are going to be people that use the same numbers, not because they know each other or something, but just because of sheer chance. Okay? So that's why with this big of a probability, there is people that win it, even though the probability is huge. Because you have so many numbers, so many people playing it, and see, that's why they do the whole Powerball thing, because realistically, some of the Powerball totals that I've seen have been like 485 million, almost got up to $1 billion once. Well, if you get up to that point, okay, so for example, let's say that it got to the jackpot got to $313 million, and you're only using 50 numbers. Okay? Well, a billionaire then could go and spend $312 million and guess all the combinations and make $1 million. Okay? That's why that anytime you see this, it's always a rigged deal. Okay? Just think about this. The other day, I think with that 485 million Powerball one, they said they had over, I'm trying to remember the numbers, they had over 500 million tickets sold. Okay? Well, nobody won it. Okay? So they basically, on that one thing, made the money that they need to pay back to people. Okay? So that's how it makes money, is because so many times people don't win it. Okay? And so it goes up. So they take that 500 million, and the next time it was like 785 million. Okay? Well, I'm sure they had, even more people buy it then, because, we're going to, I don't even know how you would even, I don't know. I guess you could spend that much money, but that would be, I don't know, that would be very difficult. But that's how you can figure the probability of things, okay? Like the lottery, things like that, where they use combination of numbers, combination of choices that you can guess, and we get it that way. All right? Now, most of the things you're going to look at today are dealing with word problems. Okay? They're not very hard, but let me do one example for you. It says class election. Your class is having an election. There are 3 candidates for president, 5 for vice president, 2 for secretary, and 6 for treasurer. How many election results are possible? Okay? So election results is what we're talking about. Okay, and we want to know how many possible things there are. Well, there was 3 presidential candidates, 5 VP candidates, 2 for secretary, and 6 for treasurer. Okay? So, they want to know how many possible combinations. Very simple. These are the amount of outcomes. Okay? 3 times 5 is what? 15 times 2 times 6. 180. So there's 180 possible results. Okay? So it's fairly simplistic stuff. Not a whole lot to it. Now, you just need to make sure that you understand that what they're asking for. Are they asking for outcomes? Or are they asking for probabilities? Okay, there is a difference. So that was, no, probabilities would have to be a fraction. So that one, they just want the possible results. They don't want the probability if Nicole's running for president, they don't want the probability that she gets president. Okay, they're just asking for how many different ways could they do the amount of people. Okay, so make sure you read that carefully, because there's not very many of them that are probabilities. Most of them are just talking about outcomes. Okay?
So outcome is that?
Outcome is that. Probability would be like 1 over 180. All right, so your homework, not going to take you a whole lot of time here probably. We have 13.3, 1 through 16. Okay, we still got 20 minutes almost left. You should be able to easily complete it in that time span. All right, we're going to work singles today, no groups.